Hey, that'd be a great way to like remind yourself how to do something. Just get it recorded on the thing. Oh, what,
I need to
yeah.
pick up.
Yeah. What did I need from the grocery store? Hold on, let me pull it up.
All right, I think we got through 17 and we're starting 18, right?
Correct. Also, I have this for you. We have some other fun little worksheets that
Oh,
we
good.
haven't quite gotten to, but
Okay.
this will just kind of give you an idea of what we have to choose from in the repertoire.
Okay.
But this is yours. We
Okay.
finished that today.
No,
Okay.
Richard, to the cap.
Oh,
It's
okay.
been rolling towards the edge of the table.
Yeah. So we're still going over this, but that was that derivative worksheet.
Okay.
And then we have some more derivative practice, and it's like intervals. So,
Okay.
anyway.
All right, good deal.
That's all we got. In case we run.
Okay. But you want to continue where we were?
Correct.
Okay.
I was just letting you know this
Right.
is what I have.
Okay. Number 18. Oops, I forgot to do this.
Number 18. Oh, this is done than the other. So I got not to 9 over here. 18.
Okay. Number 18, the position of a car T minutes after driving in a straight line is given by S of T is equal to 1/2 T squared minus 1/12 T cubed. Everybody on the same page, right? This is 18. And by the way, this is calculus contest.
2008. What's that? Yeah, 2008.
2008. Okay. So there is the position of a car. The instantaneous velocity of the car at t equal 2, and that would be minutes. They don't list that, but it would be 2 minutes, is what? How would you get that?
Instantaneous velocity, that's when, don't you just, no, it's not when you plug in. You have to,
That's position.
you have to subtract
Okay. It's,
final versus initial.
okay, that would give you average velocity.
Okay.
Yeah. This is instantaneous, though, is, what's the answer in Sunday school?
Oh, the derivative.
Take a derivative. So S prime of t is also your velocity of t. Okay? And what would that be?
So, you want to tackle this one, Richard? Sure. So you bring the 2 down. 1/2 of 2 would be 1
Right?
t.
T.
And then 1/12 of 2 would be like 1 and 11 over 12.
Okay, what are you doing now?
I would say that'd be a 4.
1/4. See, the 3 goes on top. Yeah.
Sorry.
1/4 t
Squared.
squared. Good. Okay? And now plug in t equal 2. S prime of 2 would then be 2 minus,
4.
2 minus 1.
which is 1. And that should be meters, let's see.
Meters per second squared.
Well, they don't give what the units are, so we don't know what those units are, but it's none of the above, okay? And since we're talking about Sunday school, that would be none of the above. Oh, never mind, that's just silly. Okay.
I'm done. I thought that was your writing.
18, sure enough, is E. Okay.
I have been to one too many of your classes.
All right. Everybody good on that one?
No,
So you were flipping.
yeah,
Good on that one?
right.
Need it any longer?
Nope.
All right. Number 19. The average of y is equal to sine x
Conversation about sine x.
on 0 to pi is, okay, the average of that.
0 to pi. So sine of 0 is 0.
Mm-hmm.
Sine of pi is
Sine of pi is 1.
No.
0.
Pi halves is 1.
oh,
Yeah.
pi halves, that's right.
Halves is 1. Pi would be 0 n.
Okay.
So the average of 0 to
Well,
0.
but the thing about it is you need to do an integral.
Yes, you need to do an integral. Okay? The integral will give you the whole value, okay, and then divide by the base, and that gives you the average value. Sort of makes sense? Like the integral, if this were 15 scores on the test, you'd add them all together, which is integration, and divide by 15. But this is continuous, so you do the total area under there. So the integral from 0 to pi of sine x dx. Now, integrals are antiderivatives. In other words, you're undoing the derivative. What is it that, and you may not know this, what gives you a derivative, when you take a derivative of what, that gives you a sign?
Cosine?
Okay, close.
Negative cosine?
Negative cosine, exactly. So therefore, the antiderivative of sine would be negative cosine
From 0 to pi.
evaluated from 0 to pi. Now, have you done definite integrals? I'm pretty sure you haven't. Okay, here's what you do.
That was just what we had done a problem earlier where
Right.
we had to keep where it was like the 27th
Right.
derivative or something like
Right,
that.
exactly.
From sine to cosine.
Right.
So,
Okay, yeah, you remember that. Very good. Okay, so this, what you do here is minus cosine of pi minus the minus cosine, because it's minus cosine is what you're valuing, of 0. That's a 0, okay? Now, what's minus the cosine of pi?
1.
Okay, because cosine of pi is negative 1, so that would be a minus minus 1. Minus a minus, and what's cosine of 0? 1, okay?
Plus 1.
So that gives you,
1 plus 1.
hey, didn't know you were doing such high-level math today, did you? 2 over, okay, 2, that's the integral. Then divide by the interval, okay, of that, which is 0 to pi, so you divide by pi.
Yeah, you don't die.
Yeah.
It's what is it? The first minus, or the last one minus the first.
Yeah, okay?
That's D.
So this should be D. And sure enough on the back, 19 is D.
So how do you pronounce that? 2 pites.
Yes, 2 pites of a pie. Okay,
2 pites.
okay. Number, you need that any longer?
And you said that that was the definite integral.
Yeah,
correct?
when you have
Parameters.
parameters on the end, the ranges of it, that gives you a definite integral. When you don't have these, then you do whatever this is plus c's, plus some constant.
That's an indefinite.
Yeah.
So with definite integrals, usually you'll get a number,
Yeah.
something like that, and then with indefinite integrals, you'll usually get some kind of expression or equation or something.
Yeah, with a plus c. But if you think about it, this would have been this thing plus c minus this thing plus c. Well, the minus plus c minus c, they go away. So that's why you don't need the constant at the end. Yeah,
Gotcha.
because it's the same c. Okay. Any other questions on this one?
I see.
Yeah.
That's yes in Spanish.
Yes. I said that. Okay, sorry. All right.
I didn't hear you.
All right. Okay. That was which, number 20? No, that was 19. No, yeah, that was 19. Ready for 20. Okay. I shouldn't do this while I'm doing the thing, but it reminds me of an old joke.
Oh, God.
Yeah, it's a prison joke.
Uh-oh.
This guy just got thrown into prison, and he was sort of scared. This older prisoner had sort of was helping him, break in kind of. And at supper that first night, someone just called out, "Number 83." And they all just started laughing, just roaring with laughter. And then later someone said, 105. Oh, yeah. And then sometime later, 13. Oh, yeah. And then later the guy was like, what in the world is going on here? What's funny about those numbers? So he got his old guy and said, what was going on at supper? He said, oh, I forgot to tell you that. You know, we've been here so long, we know all the jokes. And rather than tell the jokes again, we've just numbered them all. So we just call out the number and then we laugh. He said, oh, wow. So then a few meals later, when he was getting a little more confident and stuff, the young kid said, 37. Everybody just sat there and looked at him. And he felt so small. So later, when he had it along with his mentor, he said, what did I do wrong? I mean, what was wrong with 37? He said, look, kid, some people can tell a joke and some can't. So, never mind. He knows my jokes before I finish them, so never mind. All right.
Some people get, I like that.
The value A such that y is equal to x, ax,
Can I ask you a question?
e to the x. That's axed, yeah, okay. You axed me one, didn't you? Okay.
I asked.
Okay. Satisfies this dy dx minus y equal 4e to the x.
Is it bad if I want to put that in differential form?
Let's not, okay?
Yeah, that's not the kind of math we want to be doing.
Yeah.
Right now.
Okay, but this can be done without differential equations. It looks like differential equations, okay? The value of A such that this thing satisfies that, okay? What you reckon we're going to do first?
Take the derivative.
Ah, very good.
Well,
dy
that
dx is equal to,
We just learned that the derivative of e to the x is
You
e
like
to
that
the
one.
x.
is e to the x.
So, will that help us?
That helps us.
Okay.
That
But
helps.
this also is a product rule
Okay.
because this is two things multiplied
We
together.
also took, so you get the derivative of the first times the derivative of the second.
No, okay.
Or-
Close.
No, sorry.
It's, and you do it in any order you want to. The way you started, derivative of the first times the second plus the derivative of the second times the first.
Low, high,
Second
high,
thing.
low.
No,
Except,
Except you take off the denominator. and
right,
you
okay,
go-
right. Yeah, you're doing quotient.
Right.
That was the quotient rule. For product rule, it's just first times derivative of the second plus the second
you
times
can
derivative of
think
the
of
first.
it, what trig function when you have like an addition inside of it
Yeah,
and it ends up being sine, cosine, cosine, sine.
yeah,
It's similar to that. That's
Yeah.
kind of how I picked it up really quick because I just transferred from trig to this. If
Okay.
you do, it doesn't matter what order. You just
Right.
do first thing plus the second thing for
Yeah.
multiplication, and it's the derivative one plus the normal, like the regular other, and then the derivative of the other plus the normal.
times the normal.
Yeah.
Yeah.
Now, in quotients, the difference matters. And that's why you have to start it right, low d high minus high d low
It's
over low squared.
low, high, high, low.
We used that today, and
Oh, you did?
I blew Miss Martin away because she's like, how did you know that? I was like,
A
the
review.
math prep team, that's all that Cameron and Mr. Fowler use is the derivative. And
Did you say Lodi high, high, low? She didn't say that.
Did she use
she
that?
caught on to it though, but
Yeah. Okay.
Because he got that. You got that from a guy.
An Indian student that I was tutoring, and that's how they remembered it.
Like,
But you
across
knew
an
it too,
ocean
didn't you?
Indian.
Huh?
Like I said, across an ocean Indian.
Yeah. Well, I thought you had run into it in high school or something. You had.
No, I
Oh.
done that with you.
Oh, wow. Amazing. And you remembered it. Okay, never mind. Okay.
One thing.
That's it. Okay, that was it. Okay. All right. So how do you want to start?
so
Take it or
you
leave it.
take the derivative.
Of which?
AX.
Okay, and what would that be?
That just be A,
A,
times, no,
yeah,
times e to the x.
got it,
Okay. And plus,
plus,
the derivative of e to the x is just e to the x
all right,
times ax.
Times
A to the
AX. Yeah, you got it, okay? So, that gives you that part. So, let's plug that in. Now, I'm going to rearrange it ever so slightly. Ax e to the x. The reason is sometimes when you have an exponent and my writing's a little squirrely, you know, I want to make sure that I'm reading it right, okay? Plus ae to the x, that's the dy dx, minus y, which is minus ax e to the x.
Well,
Right,
those two
that's what I-
cancel. Are they right?
Okay, yes, these two add to 0, okay? And that's supposed to equal 4e to the x,
So
if
we
I
know
could
what
write.
it is.
So what does A?
A has to be 4.
A is equal to 4. And is that an option here?
Yes, it is.
Sure is. Number C.
Number 6.
Okay.
That makes sense.
20 is C.
Cool.
All right. Got it? Go to the next one. Okay, 21. All right. Derivative of d by dx of x to the x power. Not a very, now,
I'll let you handle it.
if x were a number, piece of cake. The exponent x were a number, we know how to do
You
that.
just take it down,
Okay,
subtract.
but with x raised to the x, you can't use that rule anymore, okay? Okay, that only works with finite numbers as the exponent. So here's what I suggest you do. Do y'all have a suggestion? Okay,
Nothing off the top of my head.
okay. This is an exponential equation.
I was gonna say you could do like a logarithm.
Okay, let's do something called, sort of like a substitution. Let y equal x to the x. I'm sorry, I can't write. Okay, so basically what we're looking for then is dy dx, right? Okay, now what I want to do is take a log of, because that undoes an exponent, log of both sides. Let's do the natural log, ln of that, okay?
Because it's base E.
Yeah, so this is log y is equal to, now you can use your, let me make that look a little better here. Okay, that's not super better, but, well, there we go. Okay, the property of logarithms, logarithm of a base raised to a power,
It'd be x
x log
log x.
x, x natural log of x. Okay, now, we didn't have to do it that way, but I thought that would be more illustrative. Now you can go back and do, this is the same as take an e of both sides, and that would be y again is equal to e to the x log x, right?
I was about to say, I mean, B is x log x.
Okay, so may or may not be.
I'm trying to,
Right.
maybe I'm premature on that.
So let's then do derivative of this. So dy then, dx, would be,
It would be. That's a product rule in the.
okay, yeah, in the, after you do, so it's first e to the x log x, right?
Right.
Okay, then you take the product of the argument, which is, this is the chain rule, by the way, and this would be derivative of x log x, and that's the product rule. What would that give you?
So the derivative, excuse me, so x times the log
Derivative of log x.
x, so wouldn't that just be log?
No,
Oh,
derivative,
so that'd just be,
no, you may not know this one, do you? Okay, derivative of log x is 1 over x.
okay.
So x times 1 over x,
Oh, that looks
That's the first part. That works out nicely. Plus
Okay, so log x.
log x. Yeah.
And then, the x.
Okay, I thought that you were giving me the answer. Okay. So what do we have here? E to the x log x times 1 plus log x. Now you could write that in front, or you could put e to the x log x plus log x e to x log x. I mean, that's an answer. Is that one of the ones listed here?
Let's see. E.
Oh, and e to the x log x, by the way, is
X to the
x to the
x.
x.
Right. So that's
Right.
A.
1 plus log x. Okay? Yep, we got an A.
Awesome.
And did they get an A?
So
Good for them.
And that's yeah,
Alright, so-
because the 2 go out and then that x is raised to the
Yeah.
other.
So food for thought. How would I write this? So would I write f prime of x equal, or I would write f prime of log x equals
1 over x, yeah.
Okay.
Well, wait, no, wait. That's not quite the way I would say it. I would say, okay, yeah.
He was trying to
D of log x
Okay.
dx is equal to 1 over x. That's probably the neatest way to write it. Or you could say let f of x be log x and f prime of x would be 1 over x. If you wrote all that out there, but this would be the,
if you were if
most
you,
clear.
basically if you wrote y equals natural log of x, y prime would be 1 over x.
yeah, that's another way to do it, yeah.
Just
All these different,
there's
notations,
ways
right,
to write
yeah.
the same thing.
yeah, we can blame
Leibniz?
Leibniz for this notation. I don't know who came up with the primes. Newton came up with dots, but he was using mostly time, and some people still use a dot for derivative with respect to time. Okay.
What else? Okay, was that really the only thing that I thought there was something else that I didn't know, or that was probably it. I just want to make sure that I
Right.
write down things that I don't know.
Right.
That way I can have it in my notes, even
Right.
though I'm working it out with y'all.
Right.
I want to make sure that that sticks.
Yeah.
So.
Okay. Ready for our next one? 22.
What's going on there?
If f of x is equal to x cubed plus 2x
That's the.
and g of x is the inverse of f of x. Let me write it as f inverse of x. That's the shorthand of doing it, rather right. G is the inverse of f of x. Then g prime of 3 is equal to what? Now
So
this, yeah,
Just kind of an overlay of what steps we'll be taking. Find the inverse of f, and then we're gonna, or well, you find the inverse of f, take the derivative of that, then plug it, right?
and then what?
And then plug it after inverse
Yeah.
derivative.
You certainly could do that. That certainly would work.
There's
Okay.
a shortcut I'm taking.
I'm sure there is. I'm trying right now to remember what the shortcut is, but it probably is not worth trying to memorize. So more than likely, we might at the end say, "Oh yeah, okay," but we'll see. Okay. So you remember how to find the inverse?
Oh. Put everything over 1.
Okay, that's the multiplicative inverse.
You
We're talking
put-
about functional inverse.
You change f of x to y.
Ah, good first choice. Equal x cubed plus 2x.
And I think you got to switch the variable. Right?
Yes, okay. So then you say x is equal to y cubed plus 2y.
Oh.
Yeah.
Gotcha.
That may be reminiscent. That's a
All right.
an older one.
Now you've got to solve for y. And that's where you start having problems. Okay? So, what I would suggest is we not do that. Because this would be really, really difficult to do. In fact, if it's even possible to do. Okay? Now, I'm trying to remember. Let's sort of do this. 0 at 0 and minus 2 at 0, right? Okay.
What do you mean minus 2?
Yeah, I'm graphing that function f of x. Because, oh no, minus square root of 2. And positive square root of 2. Okay, because you see you can factor out an x times x squared plus 2. No, that's irrational. Ooh, that's minus. So this isn't going to work. Okay. These are not 0. Oops. Go back. Okay, let's try that eraser again. Okay, now it's working. Yeah, this is irrational. Okay. I mean, not irrational, complex. Okay, but 0, 0 is a root. It doesn't have any other roots. And that's why you can do the inverse. And let's plug in some values. 0, 0 will work. 1, 3 will work, right? Okay. And negative 1.
Would be
negative 1. No, it would.
Because negative 1 cubed is negative 1.
Yeah.
Plus a negative 2.
Right. Okay. So basically, it doesn't look like that, but it's something like that.
It's going to have shoulders, probably. Well, maybe.
To have an inverse, it has to be monotonic. So
Yeah,
it may have, more of a shoulder, but it doesn't have a hump.
It's not going to go like
Right,
that.
exactly. That's why I was worried the other way. Okay, but okay. Now, the inverse function, do y'all have a preferred color? Blue. Light or dark?
Dark.
Dark. Okay. It's going to be something more like this. Right? Okay. Now, and this is G. G prime at 3 is going to be something like this. Okay? So F prime at 3, whoops, I ought to be in black, but you got the idea, is going to be like this. Now, same sign, but I'm pretty sure reciprocal of each other. The flatter this is, the steeper that is. But they're not opposite reciprocals, just reciprocal. So, if we know what F prime is, then G prime is going to be the reciprocal of that, I think. Okay? So let's do it. Say again?
3x squared.
Okay? So F prime of x is equal to 3x squared plus 2. Okay?
Plug in a 3.
Okay, yeah, but no. Okay. Remember, we flip our x and our y. And that was something I was...
Maybe we should have did the derivative first and then flipped it, since we had...
Yeah, no, okay. But here's the other issue. Remember, we've reversed our variables too. So we need to find out what f of 3 is. What would that be?
The, 33.
33. But what, more importantly, we need to know, and we already know, that f of 1 is 3. We did that one before, remember? Okay? So therefore, G of 3 is equal to 1. Because they're they're inverse functions of each other. So,
and we know that G prime.
so what we need to know what F prime.
Oh, excuse me.
Okay. Yeah. So actually, yeah. Actually, we're looking for that derivative. Let's see, that's not quite right, is it? Yeah, I think these are the ones that we would be. So I think we need F prime of 1. I'm trying to remember this. I'm sort of doing it by the seat of the pants. That would be what? F prime of 1.
That would be
5. Okay, that's why I wrote it down. Okay, right. Okay.
Well, I mean, I plugged it in. And
Right.
Double checked.
So G prime at 3, I'm pretty sure then it's going to be 1/5. Is that a possibility here?
That's the right answer.
That's B, and it is the right answer. Okay, well, good for them. We did work our way through that.
Work through that logic.
Yeah.
One more time.
Okay. This is approximately the first function. I mean, it may have some other variations on it. Whatever it is, then the inverse function's like that. And just as a maybe memory aid, remember it. Ooh, I thought I was in red. Okay, there we go. It reflects across the identity function.
Oh.
Yeah. Remember that?
We have used the squeeze theorem for this.
I doubt it.
Okay, well, because I was going to say, typically the squeeze theorem is sandwiched between two functions.
Right.
And it
But
meets
see,
Yeah.
the
the
thing
middle. But I didn't
about
know.
this is they cross. They don't touch. They
Yeah.
cross.
Yeah, these actually cross here. And at 0, we know they're the same. So, but no, that I know what you're talking about, but that's not the same as this.
It
Yeah.
graphically looks similar.
Yeah. But this function, f of 1 is 3, and f of 3 is 1. Okay, so maybe this is the one I should have been doing. Yeah, that's probably it. And these two would then, I think, have to be reciprocals of each other. I drew it down here, but it should have been up there. And that's,
So 3 and 1, 1 and 3.
yeah. And then I think there they have inverse reciprocals.
And
I mean,
think
not
you were right.
reciprocal. Second.
I think you were right with the first one because, well, no, because f of 1.
F of 1
X
is 3.
1,
Yeah.
Y is 3. So
Yeah. Yeah. So I think these are the two that are reciprocal. The slopes are reciprocal. So therefore, if you know the reciprocal, if you know the value here, it's a reciprocal there. Okay?
Okay. And then you took the derivative of both.
No, you never took the derivative of G because we couldn't even
Oh,
figure out what G
F.
is, right?
Okay.
Yeah. But you have to have the function that gives you that as an answer for F, and we had gotten that earlier. Okay, so that then clues you in on where we're trying to determine this, and then that gives it the rest of it. Does that kind of make sense?
Yeah.
I'm sure there's a neater way to do it. I just don't remember the formula and stuff like that. It's out there somewhere, but look it up. I mean, but think through the ones you can't do. You know, just get you a clue. You know.
I think I also was just kind of working through my head. I know now why A and D are choices, because by that same note, F prime of 3 would be 29.
All right.
And then I'm guessing if
Yeah.
just working off that lot, if you try to just take, you know what I'm saying? Work,
Right.
You know, put that over 1.
Yeah.
That would be so.
Yeah.
Got it.
They throw some pretty good false answers in there.
Yeah.
It is pretty.
Yeah.
I like the ones that give hamburger as an option. You really know that's not it.
And I'm a rib man. Okay. So let's go to 23.
My
Do y'all need this anymore? Okay.
my engineering class in high school, my engineering instructor, hamburger and stuff like that.
All right. Okay, this is 23. If f and g are differentiable, okay, functions where f of 1 is equal to 3, g of 1 is equal to 2, f prime of 1 is equal to 4, f prime of 2 is equal to 3, g prime of 1 is equal to negative 2, and g prime of 3 is equal to 5. And h is defined as h of x is equal to f of g of x. Then h prime of x, no, h prime of 1. Let's do h prime of x first, and then we'll plug in. What is h prime of x? Now, this is chain rule, okay? In chain rule, you start with the outer and work your way in, okay? So it would be f prime of g of x, right, times g prime of x. Okay? That's the chain rule. So h prime of, what were they asking for? 1 is equal to f prime of g of 1 times g prime of 1.
Oh, so now we just plug that in. Oh.
Okay, so h prime of 1 would be f prime of, what's g of 1?
Negative 2. Oh.
No, that's g prime is negative 2. G of 1 is 2, right? Times g prime of 1. Well, f prime of 2 is 3 times g prime of 1 is negative 2, and this would be negative 6.
And that's what they got.
And they got it right. Amazing. Okay. They're doing pretty well on this, you know? Okay. So they got an A. Not forgetting it right, because that was the right answer. Okay. Now, 24. Red-eyed?
Maybe a little.
Ready? Okay.
He said red-eyed.
Okay. Not enough sleep, huh? Okay.
No.
All right. Now, this is Cal 2, beginning of Cal 2. It's called the Fundamental Theorem of Calculus. I think this is part 2. There's part 1 and part 2. Part 1 is basically definite integrals, and part 2, I think, is this. d by dx of the integral from 1 to x squared, this is a variation of it, of sine of t squared dt.
Okay. So this is a trick.
Okay.
I don't like
All
tricks.
right. Here's a little problem we got, folks.
T and X's.
If you didn't have this out here, And whether you had this or not, that is not a function we can integrate. Because you can't use chain rule, you can't do a substitution. There's nothing you can do to integrate. It's beyond the transcendental function. It's a wacko function. I mean, look it up in a table. I don't think you'll ever find a table that tells you what that is. Okay. But the fundamental theorem of calculus part 2 says that you could, there's a little bit of a problem here, let u equal x squared. Or would it be t squared?
Probably t squared.
Yeah, let's try the t squared. Let's try that. Let u equal t squared, and this also is cal 2, yeah. Let u equal t squared. Then, unfortunately, got to do a du is equal to 2t dt, right?
Then you got to divide out a t, or 2.
Yeah, but that's somewhat of a problem even there. But let's at least divide out a 2. I think we'll be fine. Okay. But we don't have a t dt, we just have a t. But we also have, this implies that t is equal to the square root of u. Wouldn't you say? Okay. So, then you could have put the square root of u in here and put it 1 over the square root of u here. Right? Divide that out too. Right? That goes away. So your dt is du over root 2, or 2 root 2. I don't like to have the numbers following, so I like to put the numbers in front. Okay. I still think we've got problems, but let's see what we can do.
But can you pull out the 2?
Okay.
2 u.
But the fundamental theorem of calculus tells you you take a derivative of something that you're integrating, one undoes the other. So I'm real close to saying this is the sine of x squared, except for that other part. And I can't remember this is a weird one. And I'm wondering, do you have a 1 over x in front of that or something? Let's see. What is the answer? 24.
2x sine x to the 4th is d.
2x sine x to the 4th. It's d?
Yep.
Okay. So let's see. So if we had the 2t sine t squared, and then we were to evaluate that, I would have liked that far better if that was a 0, but it's not. It's a 1. But I don't think that really matters much, then that would give you
2 sine of 1. Two x squared sine x over 2x squared sine x over. Well, see
the 1 over the 1 over square root of u would be 1 over t, and that, I don't know. This one's,
well, whenever you go to plug those in, you get 2 sine of 1. 2 sine 1. And then for the x squared part, you would get 2x squared sine x to the 4th. So that x needs to be not x squared.
Yeah.
So
I'm,
from x squared to x.
Yeah.
I'm not sure on that one either.
yeah, I'll take their word for it, but I would be guessing at that one. And probably would have guessed wrong. I do remember when we did this, what to do if they did that kind of substitution, but I didn't remember. I remembered when this was the part that was changed, but this one wasn't. But with both changed, I'd have to do some head scratching on that. Sorry, I can't help with that. Okay? But you can look that up, Fundamental Theorem of Calculus Part 2, and you might be able to see that. I could run and get my book if you want me to pursue that.
We can come back.
Okay. Let's do 25. The values of a and b such that y is equal to 5x plus 1 is the equation of the tangent line to y is equal to x squared plus ax plus b at x equal 1 are, and that's what we're looking for, a and b. Okay? And we know this is the equation of the tangent line. Now,
One's the equation.
this is the equation of the tangent line. Okay. Okay, that's what that is. Guess what we do first? Take a derivative. Y prime is equal to?
Oh, sorry, you're talking about the equation up there.
Yeah.
Sorry. 2x
2x
plus a.
plus a.
Oh, that's
Got
a.
it.
Okay.
Making fun of my writing, huh? Okay. Now, where we go from there, what we're looking for is a and b. That's what we're looking for.
Which would,
All right.
hold on, couldn't we dissect the slope of the tangent line, or excuse, yeah, the equation of the tangent line? Can
Right.
it automatically know that 5 is m?
Yes. And this is m.
And then
So set it equal to
1
So
is
y
5.
prime at 1 is equal to 5.
Right.
Okay? And now, okay.
That's what
Now,
I was,
yeah,
see, that's what
not this y. Okay, wait. It's, no, I'm sorry, not 5, it's 2. Sorry. Okay, no. Let's not get too, woo!
I'm sorry.
Okay, no.
I'm not sure.
Okay.
Okay.
No. Okay. What we want to do here
All right, try.
is y prime of 1, this function here, yuck,
Y prime of 1 equals 2x plus a.
2x plus a, okay? And that slope is going to be 5.
So
No,
2x
wait,
plus
no,
a.
okay. Okay.
That sounds right to me.
Okay.
The reason why I even said anything today, we were talking about how derivatives work and stuff like that.
Right.
How the derivative is the slope of the tangent line.
Right.
But that, exactly, but that you can plug the values you get into, y minus y1
Right.
equals m times x minus x1.
Right. Okay. And that's exactly what we want to do next.
Got it.
We want to do what, and don't let the ones and things get too, this is the equation of the tangent line, not the slope of the tangent, that's the equation of the tangent line. Okay, so 2x plus a has to equal, let's see, yeah, has to equal 5. And by the way, x is 1, so this is 2 times 1, which is 2, plus a is equal to 5. So that gives us that a is equal to 3. Okay? Now, okay. Now,
We can solve for b.
okay.
Or no.
Okay. What we have to do is let's do our y, like you said, y minus y1 is equal to m times x minus x1, right? Now we know that what we have to do is get y1 and x1. Well, x1 is 1.
Okay.
So what y1 is
Is that 5?
no, it's right
Oh,
here.
Sorry, you plugged that in.
Yeah,
So it'd be 1
1,
plus 3
3,
plus b.
b, right,
Got it.
okay? So that'd be 4 plus b. Okay. So we know that y minus 4 plus b is equal to,
M,
which is our
5.
5 times x minus 1. Okay, so y minus 4 minus b is equal to 5x minus 5. Okay, so we're going to add 4 and add b to both sides. Okay, and you'll have y is equal to 5x minus 1 plus b. So b must be, minus 1 plus b must be 1. Minus 1 plus b must equal to 1, because that's what it is here.
Oh, okay. So b has to be 2.
B is equal to 2.
Cool.
Okay?
Okay, so how did you get the that last one, the -1 plus b equals 1?
Because they gave us the equation of the tangent line.
Okay. Let's back off and see. Y minus y1. You got that?
I see what you're saying, because y
Yeah.
plus y equals 5x plus whatever it has to equal.
Right.
That whole thing has to
This
equal
has,
1.
right here has the equal 1.
Right.
Yeah.
So these two.
So that tells you A is equal to 3, B is equal to 2.
And that's none of these,
None of these.
unfortunately. 'Cause it all
And sure enough, that's the E over here. Good deal.
Super right.
Okay, I'm glad I didn't mess y'all up. That was kind of fresh
No.
on my brain. And I was
Yeah, but you're right. The 5 was the slope of the tangent line, so that's what y prime at 1 must be 5, but we had to plug in what that was here.
Exactly.
Yeah, right.
Cool.
Okay. Now, you ready to do tiebreakers?
Sounds good.
Oh man. Oh man.
We have
Okay, TB1. Sounds pretty serious, doesn't it?
Sounds like a strain of tuberculosis. Is what it sounds like to me.
All right. Suppose that two curves intersect at x equal a to be determined. Okay? Then from the y value of each curve, we obtain, okay, so two curves, let me write this, two curves intersect at x equal a. That we're going to find out later.
Wait, we're not on the same problem.
Tiebreaker 1?
It says calculus tiebreaker 1. Find the value of k. Flip over. Or
Oh, I'm sorry.
You were
Okay.
reading. Okay.
I did not
That's
flip
not-
over. I was on the answer page.
Oh.
All right. Sorry about that. Okay.
I think those are.
Okay.
those are the answers to the problem.
That must have been the answer. Yeah. Okay.
We
So
didn't hear any of it. Remember, I'm too confused.
I wasn't understanding what I was reading. Okay. Find the value of k such that y is equal to k over x and y is equal to 2 times the square root of x intersect at right angles. Okay? So, what must be true about that then?
Well, k over x equals 2 squared x, right?
Say that again?
They're equal to each other.
Oh, okay. Find the value of k such that they intersect at right angles. Okay, so you're saying at the point of intersection, k over x, is this what you're saying? It's equal to 2 times the square root of x?
Yeah.
Okay. All right. So then k is equal to 2x root x, which we could write as 2 times x to the 3/2 power. Is that what you're getting at? Okay. That could be,
Helps us at all.
yeah, I don't know that either. Okay. All right. But the fact they intersect at right angles, okay,
That means
I like how you wrote that.
what?
That's cool. 3 halves power.
Yeah, it's much easier to do integration and stuff like that when you write it like that.
better than square root.
Never integrate or differentiate using radicals, get them into exponents. Makes life so much easier. Okay, now what does it mean to intersect at right angles?
They're orthogonal,
They are?
right?
What does that tell you about slopes?
They are opposite. No, they're reciprocals, right?
Okay, put those two together.
Opposite reciprocals.
Yeah, you got it. Okay, negative reciprocals of each other. Okay, so,
The opposite sign, everything.
yeah.
Flip it over.
So, this y prime is equal to what? In fact, let me not do that yet. Okay? No, there's a reason. Okay? Also, I say don't take derivatives with x's in denominators if you can help it, unless your quotient rule. Rewrite it this as this: k times x to the minus 1.
Okay.
Now do your derivative. Need some place to do it. Y prime, this y prime, is equal to,
Okay, so you got. We'll start out with k.
negative k,
K, x to the
negative 2.
plus-
Very good. Okay? Over here,
Oh, k is a constant. Sorry.
yeah, okay. This is 2 times x to the 1/2.
I'm sorry to do this. Would
Second.
you explain how we got negative 2 as the next one?
Okay. Remember the rule. Here's the thing we're taking. That's
Oh, never mind.
Negative 1 times
It's
that.
n minus 1.
N minus
for the next
1.
one.
You got it.
Yeah.
Good
First
deal.
time you get a negative up there, it gets kind of fuzzy because it's like,
Yeah.
wait a minute, the
Right.
number got bigger. What happened?
Exactly. Yeah.
Yeah.
Well, it really just got smaller.
Yeah.
All right, so rewrite this here, and then this y prime is equal to what?
Good old x to the 3/2.
Nope.
X to the negative half.
Negative 1/2. Got it. Okay? And these two have to be negative reciprocals of each other.
Negative reciprocal.
So this is equal to, I want to do it this way. I'm going to put this is equal to minus x to the 1/2. Would you buy that?
So what happened to K?
No,
Oh,
no.
we brought that one down.
Yeah, these are negative reciprocals of each other. So that means that, let's get rid of the minus signs, okay? and that k is equal to x to the 5/2. Multiply each side of the equation by x squared, which is x to the 4/2, and that gives you that. Okay. But we also know from up here that k is equal to this, so this tells us that k is equal to, this seems like it's running in circles, x to the 3/2, 2x to the 3/2, and divide both sides by x to the 3/2, and you get x is equal to 2. Don't you? Wait, well, that may not be what we're looking for. We're looking for the value for
Well,
k.
we found a was 2, so our x, which is their a, is 2. So that's right.
Wait a minute, what?
They plugged in an a. They substituted.
Oh, okay.
But they get it equal to 2, so that's we're on the right track.
But k then is, that's what we're looking for, find k, and k is 2 to the, so k is equal to 2 to the 5/2. In other words, the square root of 2 to the 5th,
2 to the 5th is
32, isn't it? Yeah.
32, and then what can you pull out of that?
Square root of 32, which is 16 times 2, so that would be 4 root 2.
And that's what they got.
Good for them. Okay.
You believed in them the whole time, didn't you?
I don't know. I didn't see what they got, so I don't know how they went about doing it. I guess it was legal. This, to me, sort of makes sense, so.
They did some substituting, and I don't even want to worry about it. This makes sense.
Does this make sense to you? You see what's happening with it? Okay.
I mean, for the most part.
Okay.
This is pretty.
This is all new,
I mean,
yeah.
It's my big thing is I'm getting concepts, which
Right.
is amazing. So
Good deal. You want to
Get
do?
all the cool little tricks before they come up.
exactly.
Yeah.
You know, remember when you were taking limits for everything.
Yeah.
I don't want to talk
Gag me with a spoon, you know. And so TB2, the sequel.
We're pretty much out of time.
Or are we?
Go ahead and go.
Okay. Okay, I need to leave by 5:15. Are you okay to go a little bit longer? If you need to go, I can quit now. We can pick this up Thursday.
I mean, how long do you think this will take us?
I mean,
I don't know. I haven't read it yet.
I mean, well, we need to have something to do next time, right?
Okay.
I'm good with stopping here.
You are?
It's a
Okay.
good stopping.
Okay. So we'll pick up. Ooh, I didn't bring in a pencil. I don't like to write on this.
Here.
That's break. Okay.
Just throw it.
Yes. All right. Boy, time just flies when we do this. Because I thought we were making great time on it.
We're just having so much fun.
Yes. Okay. I will end this.